Okay, well, let's take a look at the elk question from this week's homework. And what particularly I want to help you do is to construct, without giving too much away, some helpful pointers on how you might go about simulating this. So let's go ahead and get a new script up, and we'll tile them vertically. Okay, the problem statement says that there are the 5 elk are, let's go ahead and read the problem statement really quick. It says the forest contains 20 elk, of which 5 are captured, tagged, and then released. At a certain time later, 4 of the elk are randomly captured. We want to write in our script to estimate the probability that I of the captured elk are tagged, where I is 0 through 4, so up to 4 could be tagged. And right away you should think to yourself, well, probabilistically, since only 5 out of 12 elk in the population are tagged, that it's probably going to be pretty unlikely that if I randomly sample, I'll get 4 of them. And even 3, it seems that the more likely outcomes would be 0, 1, or 2 in the 4 who are recaptured later. So let's go ahead and get started. The first thing that we probably want to do is create the elk vector. So let's go ahead and well, first of all, let's go ahead and set up the number of simulations. So let's say the number of simulations is 10 at this point, and then we'll set up the elk vector, and that's going to be the repetition of, I'm going to go ahead and repeat the value 1 5 times, and repeat the value 0 15 times. And let's just make sure you understand what's going on there. So what that's done is create a vector which represents my elk population. If there's 5 ones and there's 15 zeros, so the ones in this case are representing the elk which have been tagged and are already out there in the population with a tag on their collar. Okay, so let's go ahead and set up a results vector where we can store the results of our number of simulations. Okay, so the results vector is going to be the repetition of 0 n sim times. What that does is places a 0 10 times. So each time we run a simulation, we're going to have a place to store the number of tagged elk that we capture. So at this point, what we'll want to do is somehow iteratively capture elk and count how many we have. So how can we do that? The simplest way to do that is to do a for loop. So we'll do for I in 1 to the number of simulations. And what we're going to do is go ahead and sample the elk, and we know that sampling is a way to randomly draw out of a vector. So here we'll calculate out our sample, and well, let's not call it sample since that's a command. I'll call it captured, and that will be a sampling of the elk vector, where we're choosing 4 of them, right? We're going to go into that elk vector and randomly pull 4 out. And here's a place where replace would be important to set replace equal to false, because of course we want, once we've caught an elk from the population, we really don't want to put it back out there and resample for the next of the, I guess if we're pulling 4 from the population, we want those 4 to come out and not be replaced. So I'll just see what's going on at this point by printing print captured and end my for loop and go ahead and run it. And I guess I can see what's going on here at this point. It's saying in the first iteration I actually captured 2 tagged elk, 1 tagged elk in the second, 1 tagged elk in the third iteration, 1 tagged elk in the fourth, and so on. So at this point, we have a sense that it seems to be working. It is indeed pulling 4 elk from the population, where elks here are 0s and 1s. And what we'd like it to do now is tabulate how many are actually pulled. So what we will do is we will, in the results vector, in the ith position, we're going to store to that position the sum of captured. And the reason the sum of captured works is that the captured elk are the ones, I guess, the tagged elk are the ones that are indicated by ones, and so summing those ones tells us how many tagged elk we had in the sample of 4. And so outside of the for loop, I'll just put results and print it and see what we get. And it seems like in the 10 iterations, I got mostly ones. We did get one where we come up with no elk, and then 2 locations where we actually got 2. Let's go ahead and run it again. Here I'm getting something similar, ones and twos, a few more zeros actually, and we'll run it again, and I can see I'm getting ones, zeros, and twos. It's interesting, we haven't gotten a 3 yet. Oh, there came up 2 3s. Of course, a 4 is going to be fairly unlikely in this scenario, but let's go ahead now and run it 100 times and see what happens. And I can see when I run it 100 times, in a few places there are some 3s I see, but still no 4s. And at this point, we probably don't want to print the results out. Let's go ahead and do a table of results and let that tell us just how many we got. So zeros, ones, twos, and threes. It looks like 0 and 1 are the most likely occurrences, followed by 2 and 3. We can run it again and see, oh, this time we actually did get a 4 out of the 100 results. And so for this problem, I probably put it into a proportion table and let it tell me the proportion. So it seems like most of the time we're getting ones. But of course, we're not converging here. We don't get perfect agreement yet between between runs of the program. So it might be worth bumping this up. I'll go 2 zeros, and runs pretty quick there for 10,000 simulations. Let's see if it agrees. So fairly close in agreement. We might want to run it, put another 0 on there and see how that does. It's going to take a little longer to run. I'll let it go one more time and see. And now we can feel like we're fairly confident that we're predicting the probabilities associated with each of the outcomes here. Okay, I'll go ahead and leave it there, and good luck with your programming.